have enormous respect for somebody who does that, who doesn't have to, but chooses to have that responsibility because they've achieved fame. So we know him as America's science teacher. He's educating the public. He has a new podcast, Science Rules with Bill Nye. So please let me introduce Bill Nye.
Thank you, Arthur. I'm especially gratified by all that. It's the kind of thing you read when they write about you after you're dead. But I'm still here. So as you mentioned earlier, and as some people alluded to, we are just trying to change the world here, people. And it starts with science. So I just want to tell you a couple stories from my life and then a story or two from yours. When I was in school, in second grade, I went to school right here in Washington, D.C. Mrs. McGonigal, our second grade teacher, explained that the reason the ancient dinosaurs went extinct was because they must have had small brains. So then the mammals, you know, the rabbits and rats, took all the dinosaur food and dinosaurs died. And even Mrs. McGonigal was like just looking at this big word, no. You know, I'm a Tyrannosaurus, and there's a rabbit. That's it. That it was just a silly idea. So I was a grown-up, you guys. I was out in the workforce when people made a couple of rudimentary observations that changed everything. This would be the planet Mars. Actually, it's a picture of the planet Mars. Mars is quite a bit bigger than even this screen. And you can see, even from here, that Mars is covered with craters. When you look closely at Mars, it's got all kinds of craters. So people reasoned that if Mars had been hit with all these rocks, maybe the Earth had been hit with a lot of them. And then geologists went around the world. This is well known, that people had talked about it, but it was really Walter Lewis Alvarez, who realized that everywhere you went in the world, you found this layer of the unusual metal iridium. Iridium is, anyone? Atomic number? It's right there, people. 77, and older reference. And this is an odd number, and it's not as commonly made in exploding stars, but it's very uncommon on the Earth's surface, but it's common enough in asteroids, because it's so dense, it's presumed it sank to the middle of the Earth 4.5 billion years ago, but an asteroid, if it sinks to the middle of the asteroid, it's still in the asteroid. And so there's the famous impact in Tunguska. Some people may remember Chelyabinsk. And now everybody who's scientifically literate accepts that the most reasonable explanation for the extinction of the ancient dinosaurs was a meteorite impact. And you really almost certainly don't want that to happen again. Just it's like on a PC, it's like Control-Alt-Delete for all of civilization. On an Apple machine, I guess it's wipe. Command wipe. It's bad either way. So you all may be around when it'll be your turn to deflect an asteroid. This sounds like a science fiction idea, but a lot of science fiction is based on real science. And deflecting an asteroid is going to take, first of all, finding them. And I don't know if you've gone looking for asteroids. The old hilarious joke is it's like looking for a charcoal briquette at night. They're hard to see, but if you can get an infrared camera, an infrared telescope, you can find them. If you find it, you got to figure out where it's going, where it's tracking, and then you got to figure out some way to give it a nudge. And that's what you guys are going to get done. There is no evidence that the ancient dinosaurs had a space program. And if they did, it wasn't good enough. So that's going to be a challenge for you in the coming years. I can guarantee you there is a 100% chance the Earth will get hit with another pretty big asteroid. We just don't want it to be any time in the next million years. So then people were looking at Mars, and they were looking at the planet Venus. This is in my lifetime, mostly when I was in college. And people realized for the first time that Venus was an extraordinarily, or is rather, an extraordinarily hostile place. When I was a kid, it was presumed that Venus was this lush tropical paradise full of great-looking people who spoke Venusian, we presume. And wouldn't it be great to fly to Venus on some great rocket ship and take a meeting with the Venusians? But people realized that this picture, when you get this close, is a picture of sulfuric acid clouds. So, what? Yes, clouds made of sulfuric acid, which would be bad for us. And it rains sulfuric acid on Venus, but the rain doesn't hit the ground because the surface is so hot that the rain evaporates before it gets to the surface. That's hot, people. It's hot enough to melt lead. If you've ever had fishing weights, they would melt on the surface of Venus. I don't think you'll ever get a chance to try that. But this discovery led to our modern understanding of climate change. We compared the temperature and conditions on Mars, which is extraordinarily cold. The Martian atmosphere is 0.7% as thick as Earth's atmosphere. And the Venusian atmosphere is 90 times as thick as Earth's atmosphere. And so these three atmospheres rather, the Earth, Mars, the Earth, Venus, led us to understand that the Venusian world is kept extraordinarily hot by what we call the greenhouse effect. The Martian world is pretty cold, but not quite unbelievably cold because of a very small greenhouse effect. So I, a couple years ago, went to Greenland. I took a picture of the Russell Glacier near Kangerlussuaq, Greenland. And this next part, people, is not rocket surgery. Okay, that's a glacier. You can see where it is now, and you can see where it used to be. The glaciers are receding because the world is getting just a little bit warmer. And so you all, the ExploraVision winners of today, are going to have to save the world. Now, keep in mind that the world, or the Earth, is going to be fine, no matter what we do. We want to save the Earth for me, for the humans, for you. The Earth's going to be fine. We want to save it for us. And you guys are going to do this. It's going to be challenging, and I can't help but notice that several of this year's projects are well on their way. But there's three things we want for everybody in the world. We want clean water, renewably produced electricity, and access to the internet. And if we have those, or whatever you guys call the internet in the coming years. And I'll just tell you, we had a team mention girl power. If you could do one thing, just one thing in some sort of Harry Potter kind of way, to change everything, you would raise the standard of living of girls and women around the world. This is not easy. It's cool, but, and as I said, for decades, I don't know if you guys have noticed this, but half the people in the world are girls and women. So let's have half the engineers and scientists be women. What's the big deal? Let's go. And we have, a lot of environment. If you guys think about whether the brains would be inherently better or not, I'm not going to get into that. That's up to you guys. But we depend on plants. All the animals you've ever met, even my old boss, depended on plants. My old boss, I was never sure if he was human. He made so many bad decisions. I digress. But carbon dioxide is essential for green plants. It's essential for our life. But too much of it, too fast, can cause a lot of trouble. And you guys are going to encounter people, especially here in the United States and Britain, people who are in denial about climate change. And until those people are skated off the play, as we say in hockey, it's going to be trouble. So when you go to argue with them, point out two things. First of all, there's two reasons rather, the Earth's climate is changing. The first one is what I whimsically call reason number one. I came up with that myself. The atmosphere is extraordinarily thin. If you could drive straight up at highway speeds, in Urbana, Illinois, it might take you a couple hours, but in other parts of, in here, if you want to go from Washington, Virginia, it take 2.5, 3 hours, but in other parts of the world, in 1 hour, you'd be in outer space. It's right there. Outer space is right there. This picture's not out of focus. It's the atmosphere being extraordinarily thin. Then the second reason I call reason number 2. When I was 9 years old, you guys, I came up with that myself. Reason number 2. When I was 9 years old, my family went to the World's Fair in New York, New York. The town's so nice, they named it twice. And the United Nations had a big totalizer board, a big scoreboard of the Earth's estimated human population. And when we got there, it was fewer than 3 billion people. By the time we got from my first cousin's apartment down to the World's Fair, this total board had changed from 2,999,999,999 people to 3 billion people. In my lifetime, it's gone from 3 billion to 7.5, and many people estimate it to be about 7.7 billion people. It's more than doubled in my lifetime. And that's it, you guys. That's the reason we have climate change. The Earth's atmosphere is thin, and there's billions and billions of us trying to breathe it and burn it. Now, you could run in circles screaming. Or we can just change the world. What do you say? Let's go. Yes! So, these problems are solvable. I remind everybody that all the food you eat, with very, very few exceptions, is grown on farms. And farming is not natural. If you stop farming, the prairie or the forest or the desert goes back to what it was before we showed up. And that's not a bad thing, it's a thing. So we all need to accept that human influence on the world is so big, how big is it, that we are running the whole show now. Humans are in charge of the whole thing. So as you guys go forward, I want you to think about having responsibility for making good decisions about the environment, not just for the fairness issue of other species, but for humankind. The more diverse ecosystems are, the more robust they are, the more they're able to accept change, and the better chance we all have of having an outstanding life. As we say, if you couldn't pick where you were going to be born on the earth, if you couldn't pick where, you couldn't pick which country, which tribe, which city, which farm, which village, which mountain region, which seacoast, but you could pick when. You could pick when you'd want to be born. This is the time. As messed up as things might seem to be, especially for some of the grown-ups, the world is actually much better off for humans than it's ever been. You are part of the most exciting time in human history. It's just fantastic. When I was young, people, there was no internet. Yeah, what did you guys do all day? Yeah, we came up with something. When I was young, calculators did not add or subtract. They didn't tell you where the decimal point was. And if you ever see the old footage of old rockets where they start to take off, and then they have trouble, and they fall over, and explode. That's because all the calculations were done with sign rules that didn't tell you where the decimal point was. You guys are living in such an exciting time. If we can get clean water to everyone in the world, it means people will be able, first of all, they'll be healthy. They have much less chance of getting infections. And then more importantly, perhaps, is people will be able to farm. We'll be able to have agriculture for everyone in the world. By the way, you all will feed 9 billion people, maybe even 10 billion people by 2050, 2060, with less farmland than we have today because of innovations in agriculture. Because you all are going to manage genes of crops with cluster regularly interspaced short palindromic repeat CRISPR technology. It's going to be cool. And then we want to get electricity to everybody in the world. When we talk about energy, we're talking about electricity. Electricity is amazing. You can have a clicker for your electronic slide presentation. You can have a computer, you can have a mobile phone, you can have electric vehicles, or you can make toast, all with the same thing. And so if we can electrify all ground transportation, all cars, trucks, buses, and trains, then we can slowly change the electrical grid to renewable energy, and the cars, trucks, trains will not know the difference, whether you're making electricity in a nuclear power plant, a solar panel, a wind turbine, or some future fusion machine that you are going to figure out. So this calculation is, I really find compelling. It's done by these guys, these people at Stanford University, they're mostly civil engineers, where they believe that you can power the whole United States renewably by 2050 if we just decided to do it. Not close any nuclear power plants that are working, leave those there. Work on other technologies, keep that going, but provide wind turbines and solar panels and a new or improved electrical grid to allow distributed electrical generation and distribution so that we could provide renewable energy to everybody. Now, some people think these engineers are thinking a little too wildly, but at least they're thinking. And they claim that we could run the whole world 100% renewable by 2050, and we'd have millions of jobs, new jobs, jobs needed to build the infrastructure and keep it running if we just decided to do it. Now, it's not possible, so that would be clean water, renewably produced electricity. It's not possible, or not feasible, or not reasonable to run wires to every citizen of the world. Everybody is just too spread out, it's too remote, some areas are even West Virginia, which is in the United States, is too rugged, really, to practically run wires everywhere. But if we can provide a constellation of satellites at low Earth orbit, we can hand the internet, or whatever you all come to call the internet, the electronic superhighway, the information at your fingertips, whatever, we can hand it from one satellite to another in the same way we hand mobile phone calls from one mobile cell to another. This is a solvable problem that you all are going to be part of. So I think about this quite a bit, you guys, the following thing. When my grandparents were born back in the 19th century, not only was there no internet, no one really knew anything about relativity. Relativity was discovered when my grandparents were teenagers. And relativity, at first, seemed to be a scientific curiosity with no real application. But now, I see many of you taking my picture with your phone, which depends on both special relativity, the speed of spacecraft relative to the Earth's surface, and general relativity, the speed of clocks as affected by the Earth's gravity. We all take this for granted. They're so cheap that people in the developing world have phones and have never seen a landline phone with a coily cord. Sorry, the phones used to, they used to be shaped differently. But that discovery led to this technology which has changed the world. And so, as I say, when I was in school, everybody, we had to look things up. You had to go to the library, look in paper books. So, paper. This was information storage, plant-based, that you could carry with you. And it wouldn't change. It's a long story, but don't worry about it. We can talk about it later. But that all has changed. We're having to look things up. The difficulty is not an impediment anymore. It's straightforward. The difficulty now is sorting out the good information from the bad. And that's where you all, as scientifically literate citizens of tomorrow, You're going to have to get good at that in order to change the world. Now, just a few weeks ago, people produced this picture, we call it a picture of a black hole. Now, first of all, just that we run around all day saying black hole, and we all accept it as a thing, is really remarkable. When my parents were growing, when they were your age, no one used this expression, black hole. No one had ever stopped to think there might be a star with so much gravity. How much gravity is there? There's so much gravity that not even light gets off it. No one even thought that such a thing was possible, let alone be able to get a picture of the shadow of it. So you guys understand the reason this picture exists is because scientists figured that there must be a star so powerful, with so much gravity, that light cannot escape, yet there would be this ring of orbiting photons, particles of light, and then as particles of light from other stars came by it, they'd get slung around and slung this way in an asymmetrical way, so it's brighter on the bottom than on the top. It's really an amazing thing that people inferred or figured out that these objects would exist. They would find one that they could take a picture of, and they did. Now, when I was in school, everybody presumed the universe was slowing down, that there had been a Big Bang, another extraordinary idea. There had been a Big Bang, and except in space, there's no sound. And the universe was expanding, and it was slowing down, slowing down, slowing down. There was enough gravity out there that everything would slow down, as near as anybody can tell, indefinitely. Slower and slower and slower without stopping. In my lifetime, right as a few of the older of you were born, but before most of you were born, people realized the universe isn't slowing down at all. It's accelerating. And the reason it's accelerating is because of dark matter. Dark matter. Something with so much gravity is pulling the universe apart, but you can't see it. And then the dark matter is held somehow in place, or it follows a pattern because of dark energy. Nice. Dark energy. The energy you can't see. So does anybody know what dark matter and dark energy are? No, nobody knows. But in your lifetime, I'll bet you all figure it out. And I would not be surprised if the discoveries that are created or come to be or made because of our understanding of dark energy and dark matter end up having commonplace technology akin to our mobile phones. And that will happen in your lifetime. So in the meanwhile, you all, I want you to provide clean energy, renewable energy, clean water, and access to electronic information for everybody in the world so that you can, dare I say it, change the world and save it for humankind. All right, before we go, we're just going to do a fun demonstration. Is that okay? Sure.
An ordinary serving tray stand with an official size and weight trash can with a hole in it. And now we need a product of millions of dollars and years of research, a candle, and some volunteers. All right, we need some volunteers to climb out you, sir, in the black coat. Please, can you handle this? Okay, I mean, this is, if you recognize this object, come up here. So what's your name? Do you know? That's a joke. So we're going to light the candle. Now, you know that, wait, steady. It's simple. So, Akarsh, if you took the candle over to this carpeting, you could, or maybe the banquet table cloth, the apron, you could set that on fire. And that would lead to the fire, to the burning of these wooden trim, which would cause this building to catch on fire, which then made all of Washington, D.C. and the whole so-called Northeast Corridor into this huge firestorm. So don't do that. If you're riding your bike, do you ever just turn and steer into a brick wall? No. Don't do that. All right. Here we go. Can you hold the candle lower? Yeah. So with this precision trash can and the precision clear plastic shower curtain, which has been stretched over it, we can create puffs of air with so much speed that the candle will be extinguished sometime. But the problem is we don't know where the air's going. So if I point it right at him, maybe you see his collar move, maybe a little bit. But with this precision theater fog machine, product of millions of dollars and years of research, we can fill this with theater smoke, which I have been breathing for years. And you can tell I'm fine. We can create not just a puff of air, but these extraordinary shapes, which have always charmed me. They're vortex rings. When you all take fluid mechanics, and I hope you do at some point, this you'll go through a particle of fluid, Mr. Blob, we like to call him, and it's the Navier-Stokes equation. It's all this wonderful stuff. But when you make a circle, everything cancels out, and you get these crazy rings. So the ring is moving pretty slowly, but the air in the ring, where the ring is formed, is moving quite fast. So if I can get the edge of the ring to catch a Karsh's candle, we can, it is to be hoped, same day. Oh, so close. Okay, steady. I've got to tighten the shower curtain. Good. Are you okay? You were shaking up. You're good. So we need another volunteer. We need another people jumping all over the place. Woman with glasses, girl with glasses. First team. Your name alludes to me, sign Alice. It's like that. Come on up. You recognize this? They're pieces of paper. So I want you to hold, what's your name again? Help me. Isha, okay, cool, thank you. Can you hold this to block the stream of air going toward the candle? You're blocking the stream of air. Here we go. Nothing's happening. Is the candle moving at all? Because there's a piece of paper in the way. Now, we will trade you the piece of paper for this soccer ball. Now hold the soccer ball between here and the candle. And what's going to happen, Bill predicts, air pressure in the room will hold the puff of air close to the ball. And then when it gets over here, because of Bernoulli's principle, or Bernoulli's principle describes what happens, the molecules of air